Hello, in this video I'm going to be introducing you to complex conjugates as well as division of complex numbers. Now I'm going to timestamp each part of the video below so you can just skip through to whichever part you want to see, and if this video is useful then please do like and subscribe. Let's start then by looking at complex conjugates. So I'm first going to define a generic complex number z, which I will have to be a plus bi, where a and b are both real numbers. And we say if z is our complex number, then its complex conjugate, which we denote as z star, or sometimes z with a bar over the top of it, is equal to a minus bi. So the only difference between z and z's complex conjugate is the sign of the imaginary part. Okay, now they have a property where if we multiply z with its complex conjugate, it returns just a real number, so it eliminates the imaginary part. And this is going to be useful when it comes to division of our complex numbers, which we'll look at in a second. So let's just see how that works. So let's take z and let's multiply it by its complex conjugate, z star. So we get a plus bi multiplied by a minus bi, like so. Let's now expand this, so we get a squared plus abi minus abi minus b squared I squared. Now notice these middle two terms will cancel with each other, and this term on the end, well, I squared is just equal to -1, so let's substitute that in. So we've now got a squared minus b squared multiplied by -1, and we end up with a squared plus b squared. And you can see by multiplying a complex number with its conjugate, we eliminate the imaginary part. So if we want to look at an actual example, let's say we define a different complex number. I'll use a different letter, I'll use the letter w. So our complex number is going to be 2 plus 3i. Well then, w's complex conjugate, w star, is just 2 minus 3i. And if we were to multiply these two together, okay, we could sit and actually multiply these out, but we know from this general result down here, it's just going to give us 4 plus 9. So we get w multiplied by its conjugate is just 13. So as I said earlier, this is useful when it comes to dividing complex numbers, but you'll also see complex numbers and their conjugate come up later when we look at polynomials. So let's now look at some examples of dividing complex numbers. So first, we have 2 plus 4i, all divided by 2 minus I. Now when it comes to dividing these, what we want to do is basically eliminate all the imaginary parts from the denominator. So it's kind of similar to rationalizing the denominator, because in that we're trying to get rid of our surds from the denominator, but with this we're trying to get rid of the imaginary parts. So for this example, how could we do that? Well, let me bring this down just so I don't have to write it out again. So to eliminate this I from the denominator, what I'm going to do is multiply it by its complex conjugate. And I'm going to do that on the top and bottom because doing that is the same as multiplying by 1, so I haven't changed this fraction. So we've got 2 plus I over 2 plus I. Now remember from the result we looked at just here, whoops, I'll use a highlighter instead, the result we got here, the denominator is just going to be 2 squared plus 1 squared. You could actually multiply it out for yourself, but hopefully you can see how that relates. So my new denominator is 2 squared plus 1 squared. And for the numerator, I'm actually going to multiply this out. So I'll draw lines so it's clear to see what I'm doing. 2 multiplied by 2 is 4. 2 multiplied by I is just 2i, so plus 2i. We've then got 4i multiplied by 2. That's just going to give us plus 8i. And finally, 4i multiplied by I is going to give us plus 4i squared. So I could write it over here, plus 4i squared, which is just the same as minus 4. Hopefully you can kind of see how that works. Let's then simplify this. So on the numerator, 4 and -4 will cancel out, and we get 10i over 5, which is just the same as 2i. So we've eliminated that imaginary part from our denominator. Let's look at one final example. So here we have two complex numbers, z and w, and we need to calculate z divided by w. So we've got 1 plus 3i over 4 minus 6i. Let's then multiply the top and bottom by the denominator's complex conjugate, so w star. So I'm going to get 4 plus 6i over 4 plus 6i. So let's now expand on the numerator. So we're going to get 4 plus 6i plus 12i minus 18. There we go. And on the denominator, well, I know that's going to be 4 squared plus 6 squared. So it's a lot simpler when you remember that rule. So on the numerator then, we're going to end up with negative 14 plus 18i. Over on the denominator, we're going to end up with 52. Let's then see if this will simplify. Well, we can divide everything by 2 and we get negative 7 plus 9i all over 26. And so really, if you wanted to, you could write it as negative 7 over 26 plus 9 over 26i. And so that's pretty much it for dividing complex numbers and complex conjugates for this video. So hopefully this was useful. If it was, please do like and subscribe.